Hi, my name is Ameer Fikri and matrix number 2 is 995. I will present about my individual assignment for subject electrical and electronic technology. The first question is, what happens to the gravitational potential energy when water at the top of a waterfall falls to the pool below? Okay, gravitational potential energy, PE, at the top of the waterfall. The water has gravitational potential energy that's called PE. PE is calculated using the formula PE equal to mgh. M is equal for mass of the water, G is for acceleration due to gravity, and H for H of the waterfall. Transformation into kinetic energy, KE, as the water descends, its potential energy transforms into kinetic energy. This increases the water's velocity due to gravity. KE at any point is given by KE equal 1/2 mv square. mv is velocity of the water at that point. Next, dissipation of kinetic energy. Upon hitting the pool, the kinetic energy dissipates in various forms. Heat, slightly warming the water. Sound, producing sound waves. Mechanical agitation, creating turbulence, splashes, and bubbles. And then, energy at the bottom. By the time the water reaches the pool, most of its potential energy has transformed into kinetic energy. And the last one, energy conservation. Throughout the process, energy is conserved. The initial gravitational potential energy of the water transforms into kinetic energy during the fall. This kinetic energy is then converted into thermal, acoustic, and mechanical energy upon collision with the pool. And the second question is, briefly explain the potential of hydropower installations on campus. Encourage to provide an example of the available hydropower consumption on campus. Okay. Hydropower potential on campus, sustainable, renewable energy sources. Reduce carbon footprint and energy costs. And the last one is generates electricity from flowing or falling water. The benefits of hydroelectric facilities is environmental sustainability and financial savings. The second one is minimal greenhouse gas emissions. Next, hands-on learning for students in relevant fields. And also reliable energy source with sufficient water resources. The example of usage: university near a river installs a small hydroelectric turbine, generates 50 kilowatt of electricity, supplying 10% of campus energy. Needs if average consumption is 500 kilowatt. Based on case study that I have chosen, the University of Richmond, they explored renewable energy, no hydroelectric system deployed yet. The factors is water flow, environmental impact, and technical feasibility. It invested in solar, wind energy efficient buildings, and recycling program. The third question is, water flows over a dam at a rate of 550 kg per second and falls vertically 80 meters before striking the turbine blades. Okay. Calculate A. The speed of the water just before striking the turbine blades neglects air resistance. And the answer: first, we'll calculate the speed of the water just before it strikes the turbine blades. We'll use the kinematic equation for an object in free fall. V square equal to U square plus 2GH, where V is the final velocity, U is the initial velocity, which is 0 in this case since the water starts from rest. G is the acceleration due to gravity, and the gravity is 9.81 meter per second square. H is the H where the H is 80 meter. Substituting the known values, V square equal to 0 plus 2 and 9.81 meter per second square, 18 meter. And the second one, V square equal to 1569.6 meter square per second square. And the third one is V equal to square root 1569.6 meter per second. And the last one, so the answer is V equal to 39.62 meter per second. So the speed of the water just before striking the turbine blades is approximately 39.62 meter per second. And for the B question, the rate at which mechanical energy is transferred to the turbine blades, assuming 60% efficiency. To find the rate at which mechanical energy is transferred to the turbine blades, we'll use the concept of power, which in this case is the product of the mass flow rate and the gravitational potential energy per unit mass. The gravitational potential energy per unit mass is given by mgh, but since we are dealing with power, rate of energy transfer, we will use power equal to mgh, where the m is the mass flow rate, where the flow rate is 550 kg per second. G is the acceleration due to gravity, 9.81 meter per second square, and h is the h in 80 meter. Substituting the known values, power equal to 550 kg per second, 9.81 meter per second square, 80 meter. So we will get the power 431 and 640 watt, and if we use the point, the power will be 431.64 kilowatt. This is the total power available. To find the mechanical power transfer to the turbine blades with 60% efficiency, we multiply by the efficiency factor. Mechanical power equal to power multiplied by efficiency. Mechanical power equal to 431.64 kilowatt multiply 0.60. So we will get the mechanical power to 258.984 kilowatt. So the rate at which mechanical energy is transferred to the turbine blades, assuming 60% efficiency, is approximately 258.984 kilowatt. The fourth question, what types of renewable energy that potentially generated in UM campus? Discuss in detail your suggestion and add the reference when need. The first one is solar energy. Leverage Malaysia's tropical climate and abundant sunshine. Install photovoltaic panels on rooftops. Create solar parking lots. Develop solar farms on unused land. So the benefits is reduce electricity costs and promote renewable energy education. The facts, Malaysia's average solar radiation level is 1,640 kWh per meter square per year, based on Malaysian photovoltaic industry association. Next, we can use the wind power in campus. We can utilize micro wind turbines, especially in open areas with constant wind flow. Complement solar panels for continuous energy production during cloudy periods. And the last one, viable in northern Malaysia, including Kedah, especially during monsoon season. Besides, we can use the hydropower. The hydropower can deploy micro hydro turbines in nearby rivers or streams, provides a continuous, reliable source of energy, and it can be integrated into water management operations. As example, successful use in educational facilities globally. And the last one is biomass energy. We can convert organic waste from campus operations into biogas or other energy forms. And also we can use biogas decasters for cooking or heating, employ biomass boilers to produce heat and electricity from agriculture and landscape waste. And the benefit is manage waste and produce renewable energy. So the impact, we can reduce dependence on fossil fuels, lower energy costs, and provide practical education and a sustainability model in higher education. And for the last question, design and suggest the optimum renewable energy power plant in UM campus. Determine the electrical energy output that is generated based on your design. Okay, first, we can use the hybrid systems. Combine solar, wind, and biomass source, ensures continuous reliable electricity supply, and exploits diverse renewable resources available in Malaysia. So, if we use the solar component, we can install 5,000 square meter of photovoltaic panels on rooftops and solar canopies in parking lots. Develop a solar park on unused land, so the average solar radiation is 4.5 kilowatt hour per meter square per day. So the panel efficiency is 18%, estimated generation 1,476.75 meter watt hour per year. Okay, next we can use the wind component. Install 10 micro wind turbines 5 kilowatt each in open areas. The average wind speed is 4 meter per second. Capacity factor 20%. Estimated generation 87.6 meter watt hour per year. And for the biomass component, we can use biogas digesters to convert organic waste into biogas. Use biomass boilers for agriculture and landscaping waste. Conversion rate 400 kilowatt hour per ton of organic waste. Daily treatment of 1 ton of organic waste 146 meter watt hour per year. So the total generation, combined sources generate approximately 1,710.35 meter watt hour per year. That's all from me. Thank you.